So in this video I'm going to show you the PIV processing steps. As you see, we have different runs and I excluded the last magnet, so we will have 7 pairs of images. So the first pair of image is captured at 0.5 coordinates of travel. Then we have 1 coordinates of travel, 1.5, 2, 2.5, 3 and 3.5 coordinates of travel. For instance, if I click on them, you can see that this is the first frame, that this is the second frame. Second frame always has a kind of higher light. You can see that. But if I zoom in, you can see that it moves. Then also what we need to do, we need to define a mask because we have a solid in the flow, solid wing. So we will go to define mask. So now I need to define this mask. I will sketch it by hand. So I will choose the head of it like the leading edge. So you can see that this is the lower surface. Then so when I click on OK, this is our mask. So what we need to do, we need to define a mask. So I will choose all the images, pairs of images, click right. I will go to masking in the image, then I will choose this is my mask, okay, and I will click and I say OK, and as you see, all the wings are now masked. So if I open them, for example, the third one, now this is the fifth one, this is the second frame, this is, so you see now they are masked. What we need to do, if I go and click on the first one, if I click on insert, it chooses all of them. Okay, now all the masked images are chosen. So what we need to do, click right, new data set, and we'll do cross correlation, 64 times 64 with 75% overlap. I choose it, OK, and I will say that OK, now do it for all others. We have 7 pairs of images, so it's doing them, and you can see how it goes. (64 times 64 with 75% overlap). Now I will randomly choose one of them, for example the third one, so 0.5, 1, and this is 1.5 coordinates of travel. So you see that if I also click and decrease the scale of the velocities, you see we have almost perfect vectors, and if I go on each of them, you can see that here it is written the length. For example, here we have approximately acceleration. You can see that. So, but there is a vector that I don't like. You can see that. Or if I click on another location, for example, the 5th location, you can see that this vector I'm not happy with. Or here this vector, for example, you can see that all the vectors are in another way, but this vector is there. So what we need to do, we need to do moving average validation. So of course it is obvious that the neighbors of this vector, so if I are all of them on from left to right, but this vector is from right to left. Okay, so we need to substitute it with another one. How we do that? We go here and I click on cross correlation. If I go closer and check the zooming, focusing. Okay, I think it's focused now. Okay, if I click on insert, you can see that there are chosen 7 records. I will click right, new data set. There is a title here as moving average validation. I choose this. Then I will say that, okay, average area, which means that 3, so 3 neighbors from left and top, so 3 times 3 and bottom and right, all directions. It chooses and calculates, you see, validates the vectors based on comparison between neighboring vectors. The rejected vectors may be replaced or substituted by estimated vectors. Okay, so I will click on OK, then I will say yes. So you can see that they are fine. So let's go to the 6th one. You remember this one? Now if I click on the moving average validation, you can see that now it is replaced. If I zoom in, you can see that here it is green, it is replaced. So now we know that we have them. What we need to do, this is just for one run. If I do the same thing for the run 2 and run 3, for example run 6 and run 7, because we will use just 3 samples, then we can make the ensemble averaging. I will show you in the next video.